Now if you want to be able to change something within the vector, let's say we've got a vector, define vector 1 2 3. Let's say you want to change the 1 to the word hello. Then well, let's look at how would you do that with a list. So we've got a list 1 2 3. So with a list, what you'd have to do is basically reconstruct the whole list again. So you do like cons hello onto the coulda of ls, and that's how you get your new list. And you just have to if you want to change ls to that, then you define ls to be this again. Alright, so with vec, you just directly change it using vector set bang. Vector set bang. Now the little exclamation point is what is we call bang, and that basically like will go in there and actually change the 1. It'll get rid of the 1, you'll never have it again. Whereas you know, with this well, never mind. Alright, so vec, and the second argument is the place that you want to change. So that starts on 0, 0, 1, 2 will be so 0 is what we want to change, and we'll change it to hello. Alright, vec hello. Alright. Now again with vectors, the nice thing is that no matter how long the vector is, you can change any spot in it and it will change the same amount of time, whereas with a list, if you're changing something at the end, it will take a really long time, because you'll have to, you know, like instead of just doing coulda of ls, you'll have to do coulda of the coulda of the coulda of the coulda until you get down to you know, the very last whatever spot that you're looking for. Alright, now with strings, it's pretty much the same thing. Suppose you have a string like hello and you want to change it to jello, then how do you do that? So let's define s1 to be hello, and that function you use is called string set bang. So string set bang s1, and then we'll change the first spot. Let's say you want to change it to jello, put a J. Now this is going to actually give me an error, and I'll tell you why. Alright, another schemes that I've tried, it doesn't give you this error, so I don't think this is I think this is peculiar to Dr. Scheme. If you just have a string with quotation marks around it that you just make up yourself, then Dr. Scheme says it's immutable. That means it cannot be changed. So that's sort of a problem for some of your exercises you have to do, but there's a pretty simple solution for it, which is just use the function string copy. So if you want to have a mutable version of hello, then you do string copy hello. Alright, now let's put this, so we'll redefine s1 to be the string copy of hello. Now this is quite inconvenient that we have to do this, and it's not normal for Scheme. This is just Dr. Scheme's fault, I think. Alright, so now let's string set bang, oops, 0 to s1 there. Alright, now we've got jello. Alright, great. I don't know, I pasted that again. Okay, so let's see, I don't know if I've shown you this already, but we can also do things like make string 5, just an empty string, make string, and then you could say the character that you want to put in. So of course that's the length, and that's what you want to fill it with. And let's suppose you've got like a bunch of characters. H I O, I've put the hash mark wrong. hi. Alright. Then okay, and I already went over string set bang. Now let's see sameness, checking to see if things are equivalent. Alright, so let's say we've got okay, equivalent means that not necessarily that they're the same thing. It just means that they have the exact same value. Oops. Oh no, it means let's see, maybe equals like that. Oops. Alright, so do you notice those are both not equal? Even though they're the exact same thing, they're not actually the same vector, because I mean they have the same value but they're pointing to different vectors in memory. Alright, but if you did like equal, the full equal, which generally you always want to use, then you get true. Alright, so just be careful for that. Alright, so let's define a function called vector sum. And vector sum vector sum takes a vector, like that, 1, 2, 3, 4, and we'll return the sum of it. So 1, 2, 3, 4 should be 7 plus 3 is 10. Alright, so vector sum lambda. Okay, so it just takes a vector, lambda v. Alright, now with the list, what would we do? We'd have to add this to the coulter of the list, or to the vector sum of the coulter of the list. Well, if it was list sum, then we'd add the car of the list to the vector sum of the list sum of the coulter of the list. But this is not a list. We can't take a coulter of it. All we can do is have something where we keep track of which one we're on. So let's say we'll start out at 0. We'll take the 0 entry on the vector and add it to the next one, and add it to the next one, and to the next one. And we'll stop as soon as vector sum gets, as soon as the index is at the length of the vector. So let's define that. So we're going to use a helper function, because well, actually I'm going to stop this video and continue this in the next video, because I do believe we're going to run out of time.